In this video, I'm going to do a simple demonstration of the software tool that was developed for the application of the CERCOM Risk-Based Analysis Framework, or RBAF. I will go through each of the tabs, discuss what's included in each one, and then go through the use of the tool. There are various additional training resources relating to the RBAF and software tool on the CERCOM website. I would recommend reviewing the principles and functionality of RBAF video or user manual before completing this video. Just to note, when opening the spreadsheet, it is essential to enable macros and accept the file as a trusted document. These steps are all outlined in the user manual. The tool consists of 3 tabs: the Cover tab, the Input Data tab, and the Results tab. The Cover tab is currently visible, which provides a brief description of the model for the user to read and some basic instructions. I'll cover these as we run through the demonstration. Within this tab, there are also some assumptions associated with the development of the model and how the results are presented. This is a locked file, so it's not possible for the user to edit or amend this tab. Now I'll move on to the Input Data tab, where the user provides all the data required to perform the optimization. The example discussed in this demonstration is a comparison of different hypothetical scenarios to illustrate how the tool works for the various options. For consistency, this is the same example that is used in the development of the user manual. The table of input data used in the example is provided in the resource pack to allow the user to replicate this example and get familiar with the tool. The relevant input information will also be displayed throughout the demonstration where relevant. Before I start inputting data, just a note on the formatting convention. There are some boxes shaded in light grey. This indicates that input can be provided but is not required, and the white cells indicate that data is required by the user. For the general scheme information, the inputs can be typed into the grey boxes and the number of scheme options can be selected using the toggle buttons. The information to be entered for this example is displayed on the screen. I'll put in the project name, project number, the date, and user initials. Here I'll select 3 as the number of scheme options. The road is 200 kilometers long, dual carriageway, so I'll enter that information here. The budget available is a white cell in the spreadsheet indicating user input is required. This is used in the calculation of the Cost Performance Index, or CPI. However, this can be left blank if the CPI is not being used for analysis. There is further discussion of this in the user manual. For this example, I will enter 25 million. I'll also enter the assessment period of 20 years. And options A, B, and C as the name of the scheme options. If no names are entered here, the default is option 1, option 2, and option 3, and these headings will then appear in all further tables within the spreadsheet. The next heading is the input categories and KPIs. Under this section, the user indicates what criteria will be included in the analysis and how the various KPIs will be inputted. Here I'll add in some generic examples in the grey shaded cells, like technical performance, Cost Performance Index, or CPI, example cost 2, example circular economy 1, example CE2, example environment, and example social. The first row within the cost category is exclusively for the CPI and can be selected as cost CPI from the drop-down menu, or it can be left blank. Additional or alternative cost indicators can be added in below this row. The data being entered for this example is provided on the screen. I'll just go through now and select the input format for each option from the drop-down menu. For technical performance, this indicator could relate to factors such as skid resistance, ravelling, or other safety or durability criteria, which can be defined based on the scheme being considered. For cost in this example, capital costs are included in the analysis using the Cost Performance Index or CPI. For the calculation of CPI, numerical input must be provided. An additional cost KPI is also included in this example to demonstrate how to incorporate further cost factors such as residual value when only capital costs are included in the CPI. An alternative would be to skip the CPI step and include net present value or whole life costing as an additional KPI within the cost category. In practice, if data is available to quantify the KPI, the numerical input option would be selected. If not, the preset scale can be used. For this example, to give a demonstration of how the tool works and how various input types can be used, I've randomly selected the input format for various KPIs. It is important to be aware that when using the preset scale, there is a higher level of uncertainty associated with the result, and the user must be mindful of this when interpreting the final results. The next step is to input values for performance and risk. Risk is a product of the probability of failure and consequences associated with the failure event. For this example, the preset scale is used for the do minimum scenario and for option B. For do minimum, the performance level selected is above average and uncertainty associated with the selection is low. For option B, the performance level selected is below average and uncertainty associated with the selection is high. A table of values for probability of failure corresponding to the preset scale options is provided in the cover tab and also in the user manual. For the probability of failure, there are different scales for the do minimum situation and for scheme options being considered. This is on the assumption that any construction or maintenance option would have a significantly lower likelihood of a failure event than no intervention. For this example, for the option selected, the probability of failure is 0.6 for the do minimum scenario, and the selected inputs for option B results in a probability of failure of 0.25. Alternatively, where sufficient data or knowledge is available, numerical inputs can be inputted for probability of failure based on probabilistic methods or expert judgment. For option A and option C, values of 0.2 and 0.15 are assumed and are inputted into the cells shaded white. The consequences of a failure event must also be entered to calculate the risk. An example of consequences would be the cost associated with an unscheduled road repair or resurfacing, or cost associated with a collision. In this case, it's assumed that the consequences of a failure event would be unscheduled repair or resurfacing, so the consequence cost is the same for each scenario and are taken as €20 million. For the scenarios considered, the probability of this occurring is relatively low. For other limit states, the probability of a failure event may be high, for example, the probability of a collision. So in cases like this, the consequence cost can vary for each scenario to account for the magnitude of the costs associated with a single or multiple failure events over the lifetime being considered. More detail of this particular example is provided in deliverable D4.1 and D4.2. Cost is the next heading. It's noted that for the calculation of the Cost Performance Index or CPI, the capital cost entered for each of the options must be less than the budget entered previously in the spreadsheet. Costs referenced here are the direct and or indirect costs associated with the planned construction or maintenance activity, and they shouldn't be confused with the cost of consequences associated with a potential failure event. As discussed, there is an option to skip this step and input costs using additional KPIs for cost below, using methods such as net present value or whole life costing. The cost entered here for options A, B and C are 10 million, 12 million and 5 million respectively. The next section is to input data for ranked interpolation for the additional KPIs. The section in green will be completed for each category first, defining thresholds to map specific ranks to KPI values. Following this, the specific measurement values can be entered for the scheme options being considered to calculate KPI values. For example cost 2, two ranks are selected. 0 and 1 are entered as the data values for the least favourable rank and most favourable rank. Similarly, for example CE1, values of 20 and 100 are entered, corresponding to the percentage of recycled material. These threshold values automatically correspond to KPI values of 0 and 1. For example CE2, 3 ranks are selected. The outer threshold ranks must be defined first, with the data values of 1000 and 6500 entered to correspond to KPI values of 0 and 1. For intermediate rank 1, a data value of 3500 is entered to correspond to an entered KPI value of 0.2, defining the relationship for multilinear interpolation. For the social example, 4 ranks are selected, with distance travelled an indication of what this could represent. Again, outer thresholds are inputted first, with data values of 1000 and 250 entered for least and most favourable ranks, corresponding to KPI values of 0 and 1 respectively. For intermediate rank 1, a data value of 800 is entered to correspond to a user-defined KPI value of 0.4, and for intermediate rank 2, a data value of 350 is entered to correspond to a user-defined KPI value of 0.65, defining the relationship for multilinear interpolation. The toggle button beside the graph can be used to move through the categories and view the relationship for interpolation where 2, 3 or 4 ranks are selected. The names least favourable and most favourable are used instead of maximum and minimum because in some scenarios a lower value can be more advantageous, resulting in a higher KPI value, like for the social example given above. Input values relating to each option are now entered according to the table displayed. Some are numerical input values and some are to be selected from the preset scale. For example cost 2, the position of the white boxes under the heading Select KPI indicates that preset scale options must be selected for option A and option B. 0.1 below minimum industry practice is selected for both. A table of preset options is provided in the cover tab or in the user manual. For option C, a numerical data value of 0.1 is entered. Given the threshold values for this option were 0 and 1, this corresponds to a KPI value of 0.1. For example CE1, numerical values of 50 are entered for option A and option B. KPI values of 0.38 are automatically calculated based on the threshold values entered previously. A preset option of 0.75 far exceeds industry practice is selected for option C. For example CE2, a numerical value of 5000 is entered for option A. A KPI value of 0.6 is automatically calculated based on the threshold values entered. Preset options of 0.25 minimum industry practice is selected for option B and 0.5 exceeds industry practice is selected for option C. For the environmental example, preset options are selected for all. 0.25, 0.5 and 0.25 for A, B and C respectively. For the social example, numerical values of 500 and 825 are entered for option A and option C. KPI values of 0.57 and 0.35 are automatically calculated. A preset option of 0.1 below minimum industry practice is selected for option B. Coming down to the graph, it is possible to use the toggle to view the interpolation graph for the different KPIs. The graph shows the position of the ranks that were used to define the linear or multilinear interpolation, as well as the points corresponding to the data entered for each of the relevant scheme options. Taking this social example, the interpolation is defined by 4 ranks, as indicated by the user, and is displayed by the grey line. The points entered for A and C can be viewed. Option B is not displayed as this was a preset selection. It's also possible with this graph to visualize the difference between using 2, 3 or 4 ranks. The final step for data input is the weights to be assigned to each KPI defined. These can vary between options, but it's recommended to keep them the same for consistency. The following values displayed in the table are entered for this example. Any values between 0 and 1 can be chosen for each KPI, but the sum of all weights for each option must equal to 1. Just to illustrate, if I try to put a number greater than 1, an error appears and the value cannot be entered. Also, if the sum of values is not equal to 1 for any of the scheme options, then an error appears advising the user to revise input values. The result will not be displayed if this error appears. I'll now move on to the final tab since all user inputs have been entered. Once there are no errors with weights, the results appear or are updated by clicking on the button. Just to demonstrate, if I go back and amend the weights in the previous table, an error appears and the results are no longer visible. The table provides the individual elements of the weighted sum, or the value of each KPI multiplied by the assigned weight. The values are summed to calculate the net risk reduction gain, or NRRG. The higher value of the NRRG, the more optimal the scheme option. In this example, option C is most favourable. The graph gives a clear indication of the contribution from each weighted KPI. Given the use of preset values, the uncertainty regarding the overall result needs to be taken into consideration when interpreting the results. For lower levels of maturity, the tool could be used to give a broad indication of the various advantages of each of the options and could inform where further investment in data collection would be advantageous. In this case, given the initial results, it would be worth investigating option C and gaining more data to provide a more robust analysis. If analysis for this example was carried out using only numerical data, more confidence could be placed in the final result. It's possible to assess the sensitivity of various weights and parameters by amending the input values and reassessing the results. I hope this demonstration has provided a clear example of the use of the software tool and the flexibility to cater for varying levels of maturity. As discussed, there are various additional training resources relating to the RBAF and software tool on the CERCOM website if required. Thank you for watching.